Good afternoon. I wanted to give you guys some updates on the Chapter 6 lecture, which is on proteins. So I think when we hear the word protein, we all have some connotations in our mind of what a protein is. Some people may think of meat, some people may think of muscle, but a protein is an important part of our body. About 17% of our body is made up of protein. Water is the only other more abundant source in our body. And the unique piece about protein, we've learned in studying carbohydrates and fats that they all are made up of carbons, hydrogens, and oxygens, but proteins are unique because they contain this element nitrogen. And this is our only source of nitrogen. Even though nitrogen is in the air, it is not in a usable format that our body can incorporate it, so we have to eat protein to get nitrogen. So why is protein so so essential? Because protein is important to provide amino acids. Amino acids are the building blocks of protein, and we in turn take those amino acids and proteins and make other proteins in our body. Our body has over about 50,000 different types of proteins, and we need to consume amino acids in order for our body to make the proteins we need. Another thing that protein does is it regulates and maintains lots of body functions, things like water balance. There's a protein called albumin that is found in our body, and albumin is the protein that really maintains the proper water balance inside and out of the cells. Proteins make hormones. Proteins make enzymes. For example, insulin is a hormone that protein is made out of protein. Protein is also a transporter. We transport lots of substances within our bloodstream on proteins. Protein is how our body does growth and how our body repairs. And protein can also be an energy source if we don't have sufficient carbohydrates or fat available. So again, amino acids are those building blocks of protein. And this is just a chemical structure of a typical amino acid. And the only reason that I show you this is that every protein has this amine group or nitrogen group, and every protein had this acid group. That's where the term amino acid. This is the piece that varies from protein to protein. There are 20 different types of amino acids. There are 11 non-essential and 9 essential. Essential means that our body has to have them. We cannot make them. And we should get about 10 to 35% of our calories coming from protein. So again, remember that there are 20 total amino acids that make up all of our proteins in our bodies. So think of this a little bit like the letters. 26 letters make up millions of words. 20 amino acids make up thousands of proteins in our body. Amino acids are essential and non-essential. There are 9 essential and 11 non-essential. Here's a list of those essential and non-essential amino acids, and I do not expect you guys to memorize or know these, but just in case you'd ever heard their names or seen them, these are the ones that are essential in our body, and these are the ones that our body can make when we have sufficient amounts of these. So when we have proteins, they're basically just amino acids, which are the building blocks, bonded together by something called peptide bonds. These are the bonds that need to be broken by our small intestine in order to absorb proteins. So for example, when you eat a steak, you're eating amino acids in a storage form from the animal as their muscle, and then you eat those, you break apart those amino acids, and you build the proteins that your body needs. So what food groups have protein? Well, what's interesting is that most all food groups have some protein. With the protein, obviously the protein groups, the dairies, but grains also have protein. Vegetables have some. Fruits have very little protein. There are 2 forms of protein. And I really don't necessarily always like the term high quality and low quality, but the reason that we say it that way is that animal proteins are higher quality because they contain all the essential amino acids. So you get this full package ready to make proteins in your body when you eat animal proteins. When you eat plant proteins, you are usually missing one of the essential amino acids. And that's why in vegetarian diets, which are plant protein based diets, a lot of times you have to eat certain foods together. For example, beans and rice are typical foods that contain rice is missing one amino acid that beans are very abundant in. So when you put them together, you actually get a complete protein. So you can put plant proteins together to make a complete protein, but in and of themselves, plant proteins are not complete. The only two exceptions to that are quinoa and soy. And that will be the extra credit for this week if you email me the two complete plant proteins, which are quinoa and soy. Keep in mind in protein synthesis that you can't be missing one amino acid and still make a protein. Protein synthesis actually stops if you don't have all of the essential amino acids. That is called, when you're missing one amino acid, is called a limiting amino acid. And I'll give you an example of that. So again, animal proteins contain all essential amino acids. Two plant proteins, soy and quinoa, also contain all the essential amino acids. So all meat and dairy products have animal complete proteins. But they also have saturated fat and cholesterol, so that can be a disadvantage. Most of our diet is animal protein. About 70% of the protein that we eat in our diet comes from animal protein. And again, that includes milk, dairy, yogurt, cheese, meat, fish, chicken. The top 5 contributors to protein in the United States are beef, poultry, milk, white bread, and cheese. And what I kind of note about this list of foods is I think about our first lecture about superfoods, foods that are high in phytochemicals, and none of these foods are high in phytochemicals. So it's interesting that we're getting a lot of protein from foods that aren't necessarily deemed superfoods. Now keep in mind that elsewhere around the world, most protein comes from plant sources. So plant proteins come from nuts and beans and grains and some vegetables. These are deemed incomplete proteins or low quality proteins because not all amino acids are present in every single food. So you must put foods together in order to make up for what we call that limiting amino acid. So again, if you eat beans and rice, you're going to get a complete protein. If you eat nuts and bread, so a peanut butter jelly sandwich, you're going to get that complete protein. So why are plant proteins better? They don't have saturated fat, which we learned in the last lecture can raise our body's bad cholesterol, LDL. They don't have any cholesterol, and they're loaded with fiber. In addition, they have all those phytochemicals. So things like nuts and legumes and whole grains are very good sources of phytochemicals. One of the other impacts that's so nice about plant proteins is that when we excrete that excess nitrogen that comes with animal proteins, we typically lose some calcium along with that. And a nice thing about plant proteins is we don't tend to consume them in excess like we do animal proteins, so thus we don't lose that calcium. And we also kind of slow our glucose absorption when we're eating if we have lots of fiber in our diet, and that can help stave off diabetes. So just to check in, proteins are made up of amino acids that are bonded together by peptide bonds. Proteins are found in grains, vegetables, dairy, and the protein groups. Very little protein is found in fruits. All right, let's talk a little bit about protein digestion and absorption. Protein digestion begins in the stomach with stomach acid and pepsin, which is a stomach enzyme that breaks those peptide bonds. So we're starting to break apart those proteins into those individual amino acids. The pancreas continues to release more protein digestion enzymes like proteases and trypsin that continue to break those bonds down. So we're taking a large piece of protein that comes from a steak or chicken or beans, and we're breaking it up into amino acids. The amino acids are thus absorbed in the small intestine, and they are that's an active transport. They're then transported to the liver. And in the liver, there's several options for proteins. Okay, They can be combined in the amino acid pool in the cells to form proteins the body needs. So, for example, if you have a broken leg, you may need more proteins going to those amino acid pools that are making bone. The nitrogen part of protein could also be excreted because remember, we have no storage form for nitrogen. And the rest of the carbon shell in protein could be used as energy if our brain needed glucose or stored as fat. So the things I want you to remember from this slide is there is no storage form for protein. Protein is stored without its nitrogen as fat. So why can't we store proteins for later use? Because that excess nitrogen is excreted it's made into urea, and then the kidney secretes it in our urine. And again, those other components can either be used as energy if we need energy or stored as fat. So let's talk for a second about essential versus non-essential amino acids. Essential amino acids are the building blocks for all proteins. If there's a limiting amino acid, meaning there's not enough of a certain essential amino acid, that whole protein will stop. So the body doesn't build kind of half-done proteins. They either build them complete or they don't make them at all. So I want to give you an example of this. So let's say that the body has to make this protein. And if you don't recognize this, this is supercalifragilisticexpialidocious. So if the body says, I want to make this protein, it needs a set of instructions, and those instructions are stored in every cell. So the instructions say, you need this many letters or this many amino acids to make this protein. For example, you need 3 S's and 3 A's and 3 C's and 1 D. So those are the instructions of what you need to make this protein. So let's say you go to eat and you eat this amount of amino acids. So I'll just tell you without having to look at all these numbers. The difference is that there's only 4 I's in this thing that you ate versus the 7 I's that the instructions say you need to have. So what happens is your body tries to start making this protein, and it puts the S and the P and all this, and the I, it puts it in there once, it puts the I in twice, it puts the I in 3 times, it puts the I in 4 times, and then it gets to this place where it needs another I, and I don't have any more left. So the protein synthesis stops, and that protein is not made. So that's why essential amino acids are so critical. This is an excerpt from your book, and it kind of just talks about what I just summarized as that metabolism of amino acids. So what do proteins do in the body? Again, we rebuild our muscles, we use it for connective tissues, we use it for fluid balance, acid-base balance, we make hormones and enzymes, our immune system is made up of proteins, we can make glucose from protein by getting rid of that nitrogen, which gives us energy, and we can also store it as fat. But proteins also give us satiety. So again, protein is vital to the body. It's the only source of nitrogen for the body to build other proteins. Here's the functions that protein has in the body. But how much do we need? The minimum amount of protein we need every day for most healthy adults is 0.8 grams of protein per kilo of body weight. So for an example, if you're a 154-pound male, you need about 56 grams of protein in a day. Just to let you know, this is about as much protein as in an 8-ounce piece of meat, whether that be chicken or fish. So you can see that most of the time we get plenty of protein. There are times in our life we have increased needs for protein, pregnancy, endurance athletes, but most of us eat more protein than we need. So how much protein is too much? Well, when you start to get more than 35% of your total calories, you're probably missing other nutrients. Is a high protein diet harmful? It can be, because typically it's low in plant foods, which we've learned in this class how critical plant foods are. It tends to be high in saturated fat and cholesterol. And we also know that excessive intake of processed red meat is a strong correlation to colon cancer. You can put a burden on the kidney by having to excrete so much nitrogen, and you may lose a lot of calcium in the urine. So remember, the RDA for protein is the minimum amount, and that's 0.8 grams per kilo. The guideline for how many calories should come from protein is around 35%. If you don't get enough protein in your diet, malnutrition can occur. And I'm going to finish up with this concept check so that I can keep this under 15 minutes.